Bismillah ar-Rahman ar-Rahim. Assalamu alaikum dear students. I'm Arif, and most of you might have seen my previous series of video lectures on my YouTube channel. Or maybe from my website at this link. I'm thankful to all those students and viewers who have liked these videos and subscribed my channel and have sent their views via email. On request of many of my students, I am back with my next course of video lectures with the title of, let me open the board, Internetworking with Linux. So the title that I have finalized for this course is Internetworking with Linux. The target audience for this course are my undergrad students and all those having basic concepts of internetworking and a working knowledge of the Linux command line interface. Today's session will give you all an overview of some important internetworking concepts. In the second session, we will learn to build our lab environment that we will be using in all our future sessions. And those future sessions will mainly cover understanding, installing, configuring, and using various Linux servers like the DHCP server, for assigning TCP IP configuration parameters to the devices, the telnet, and the secure shell server for remote login. We'll talk about the Apache web server for deploying websites using HTTP and HTTPS protocols. We'll talk about FTP and SFTP server for secure file transfer, the NFS server for file sharing, Squid proxy server for caching web DNS and other lookups to aid security by filtering traffic. We will also see the details of the DNS and bind Berkeley Internet Name Domain server for name mapping, database server like, for example, MySQL. And last but not the least, we will talk about a bit about Linux security using firewalls, IP tables. So let us start playing. Move on to the next board. Let's have a brief overview of networking. Overview of internetworking. Excuse me. Well, in today's session, we will try to understand some important internetworking concepts that are the prerequisites for our future sessions. As you all know about computer network, a computer network is a set of computers connected together for the purpose of sharing different resources. You all know about the internet, which is a worldwide system that connects different computer networks, allowing hosts on all those networks to communicate with one another. And as far as internet is concerned, let me touch upon two more terms related with this. One is intranet. An intranet is a private network that is contained within an organization where the employees can access the local computing resources, and they can also access the internet using something we call a gateway computer. The other related term is extranet. You can think of an extranet as a part of a company's intranet that is available to users outside the company, like suppliers, vendors, and customers, so they can access that part of the intranet. Finally, the most famous TCP/IP architecture. Although there are various inter-networking protocols that have been devised, but TCP/IP has become the dominant protocol suite. It is a standard set of protocols developed in late 1970s by Defense Advanced Research Project Agency, normally called DARPA. So let me move ahead and talk a bit about TCP/IP protocol architecture. TCP/IP protocol architecture. Okay, so this is important. Pay attention with me. There are 4 layers of TCP/IP stack, also called the DARPA model. Let me draw those layers first. The topmost layer is the application layer. Let me box it down. The second is the transport layer. And after transport, we have the internet layer. And after internet layer, we have the network interface layer. The network interface layer. Let me touch upon these layers one after another. Let me touch them for better understanding. First, the application layer. This layer provides applications the ability to access services of the lower layers. It supports programming interface like the socket, the WinSock for Windows, and the Mac TCP for Macintosh. The protocols that are used on this layer, plethora of protocols are there. They are SSH, HTTP, FTP, DNS, Telnet, SMTP, SNMP, and so on. And all these layers are addressed properly. Every layer has its own way of addressing the things. The addresses that are used on this layer are called DNS, or domain names. For example, google.com, arif.me. These are the kind of string addresses that are used on this layer. The second layer is the transport layer. The 2 most famous protocols that are used on this layer are the TCP and the UDP. The TCP provides a reliable full duplex stream-oriented communication channel, while the UDP, user datagram protocol, provides an unreliable full duplex packet-oriented communication channel. So TCP is reliable while UDP is unreliable. Both are full duplex. TCP is stream-oriented while UDP is packet-oriented. There are other differences as well, which I'm not going to discuss right now. And the addresses that are used on this layer are called port numbers. Port numbers. We will talk about these addresses in detail after a short while. The third layer we have over here is the internet layer. This layer breaks the data into fragments. So fragmentation is done over here. Fragmentation. it performs routing. So routing is done over here. routing, routing. Routing is a mean of specifying and discovering paths along which data packets can be sent. The protocols that are used over this layer, most important and commonly used is the IP, Internet Protocol, a routable protocol responsible for IP addressing, routing, and fragmentation and reassembly of packets. We will talk about this in detail. Then we have ARP, Address Resolution Protocol, that is responsible for resolving an IP address to MAC address. We have ICMP, Internet Control Message Protocol, that is responsible for providing diagnostic functions and error reporting due to unsuccessful delivery of packets on the target. Then we have IGMP, Internet Group Message or Internet Group Management Protocol, and this is responsible for the management of IP multicast groups. The addresses that are used on this layer are either the IPv4 or the IPv6. IPv4 is 32-bit, while IPv6 is 128-bit address. We will talk about these in detail after a short while. Finally, we have the network interface layer, the layer at the bottom. This layer is responsible for placing TCP IP packets on the network medium. It places the TCP IP packets on the network medium, and of course it receives the TCP IP packets off the network medium. The TCP IP architecture was designed to be independent of the network access methods like Ethernet, token ring, FTDI, frame formats, and the medium. It can be wireless or it can be wired. And let me write it down. It is responsible to transmit and receive frames. Packets over here are called frames, and the address that we use over here are normally called the 48-bit MAC address, Media Access Control address. Okay, so now let us try to understand how network messages actually work. Let us suppose there is a sender process running on this layer. Let me change color for this. There is a process P1 which is running on the application layer of some computer. The sender process running as this layer push the network message down. Let's suppose that this is your message. This message is pushed down to the transport layer. The transport layer takes this message and attach a header to it, and this header contains the source, the destination port numbers along with some other information. We call it, let's suppose, a TCP header. It can be a UDP header as well. It moves down to the internet layer. Now this message and the transport TCP header is further attached with what we call the IP header. Normally the IP header is of 20 bytes, and it contains source and the destination IP address along with some other information. And finally this comes over here to the network interface layer, and finally the network interface layer attaches a header as well as a trailer. Header as well as a footer or trailer. And then of course it contains the MAC addresses of the source as well as the destination. So this layer transmits the whole packet over the network medium. This layer transports the packet on the medium. The medium can be physical, for example, coaxial cable, twisted pair, or fiber optic, or the medium may be wireless, for example, Bluetooth, Wi-Fi, or maybe microwave. Once the transmitted packet moves over the network cloud, it somehow finds the destination computer, and it reaches the destination computer over here on the network interface layer. And the packet moves up the stack. Each layer detaches its header, and finally the actual message is received by the target process running on the application layer of the destination computer. So this is how the TCP IP protocol architecture works. Gentlemen, let me spend time on making you understand about the addresses used on each layer, the DNS on the application layer, the port numbers on the transport layer. We will talk about IPv4 just now on the internet layer, and the MAC address on the network interface layer. So let me move on to the next board, and let me say application layer address. We normally call it domain names. Suppose you type in the address bar of a browser the address of my website, that is http://arifbut.me. Your browser sends this string to one or more servers that somehow returns the IP address of the machine on which this web page resides. These servers that fulfill this request are known as the domain name servers. Domain name servers. Remember, this string kind of addresses are easier to understand for humans, while the IP addresses are good to use by the computers. We will learn this, inshallah, this domain name server working, when in some future session we'll learn to install, configure the DNS server. For the time being, just remember that internet name domain is a name mapping service. Let me write it down. It's a name mapping service that provides a mapping between the IP address and human readable names, normally called the URIs. Okay, what are URIs? Let me write it down. URI, it is a string of characters. A string of characters that are used to identify a resource located on a specific host on the internet. And these URIs are of two types. The first is known as URL, Uniform Resource Locator, and it points to a specific resource at a specific location. For example, the format is something like this. We write down the protocol first, :/, then we write down the host address. Then there is an optional port number, the transport layer address, and then there is a slash, and then we have a complete path to the resource. Example of such an address using the HTTP protocol is, for example, arifbut.me:80. Remember, this is optional, and let me write down the path where my CV resides. Well, gentlemen, over here at the protocol part, you can write down file. If you want to browse a file on your own system, you can write down FTP telnet. You can write HTTPS, or you may write news, and there are other protocols as well. The other kind of URI is URN, Uniform Resource Name. And a uniform resource name points to a specific resource at a non-specific location. For example, let me write down a URN. URN of a book having the ISBN of 04514505523. This is the URN of a book, The Last Unicorn. So anyway, so you have a fair idea of the application layer addresses, which are known as domain names. So we will dig out the details in some future session how it actually works. And let me move on to the addresses that are used on the transport layer. Transport layer addresses. Transport layer address, and we call them the port numbers. They are of 16 bits. So since they are of 16 bits, they can occupy value of 0 to 65535. So remember, gentlemen, there can be different applications running on the application layer that may want to send and receive data over the network. And this port number, 16-bit port number, is used to identify a specific process to which a network message is to be forwarded when it arrives at a computer. There may be a machine on which there are 2 or 3 services which are running, like HTTP and SSH. So when a network message arrives on that machine, so that message needs to be sent to a HTTP server or a secure shell server or a telnet server. Where it should be sent, this is decided by this transport layer. For example, port 80 is used by the HTTP service, while SSH use the port number 22. So the types, let me write down the types. Types of ports. There are 3 main types of ports. The first type of ports are known as well-known ports. The well-known ports numbers range from 0 to 1023. These ports numbers are permanently assigned to specific application by IANA, Internet Assigned Numbers Authority. For example, the HTTP is having the port number 80, while HTTPS uses 443. Similarly, Telnet uses port number 23, while SSH use 22. You can view these in your Linux machine in the file etc services. The second type is the registered ports. And the registered ports, they range from 1024 to 49151. These are also controlled by IANA. Example of such port numbers are NFS, which runs on 2049, MySQL, that runs on 3306, and so on. Being a developer, one should not use the well-known and the registered ports, as it may conflict with other applications using these port numbers. So being a developer, you should use private ports. The third category. The private port numbers range from 49152 to 65535. They are also called dynamic or ephemeral ports, and they are used for local applications. So after having a fair idea about the application layer addresses DNS, the transport layer addresses port number, let's move on to the famous internet layer address, IPv4. I will spend a bit of time on this internet layer address. Still today, we are using IP version 4 addresses while developing our applications. The IPv6 is still the future. The IP address uniquely identifies a host on a network. It uniquely identifies a host on a network. It is a 32-bit address with 4 octets of 8 bits each, and we write it normally like 192.56.32. Let's suppose 4. So this is an IP address. Internet Corporation for Assigned Names and Number is responsible for IP address space allocation, protocol parameter assignments, and DNS management. And there are different classes of IP addresses. You can say that the IP addresses are divided into 5 different classes of IP addresses. The first class is known as the class A. Every class A network address supports about 16 million plus hosts. So it is used by very large organizations like IBM. For example, IBM has a class A IP address of 9.0.0.0. Class B. A class B network address supports about 64K hosts and is used by medium-sized organizations. The third is the class C, and a class C network address supports about 254 host computers. Then we have class D and class E. Class D is reserved for multicast, while E is reserved for R&D, so we will not be interested in these two classes. I would like to talk a bit detail about the IP addresses that belong to class A, B, and class C. So let me move on to a new board, and let us talk about class A network addresses first. Class A network addresses. Every IP address is divided into 2 parts, a network part and a host part. For example, the general format of class A network address is something like this. So it has 1 octet reserved for the network part that is used to identify the network, and 3 octets reserved for the host part that are used to identify the host on that network. Since there is only 1 octet for the network part, so there are a total of 2 raised to the power 7 minus 2 addresses. We can say 126 addresses. And these addresses are 1.0.0.0 to 126.0.0.0. So these are the 126 class A network address range. And since there are 24 bits, 1, 2, 3, 24 bits, 8 each, for the host part, so every class A network address supports about the number of hosts it supports is 2 raised to power 24 minus 2, which comes out to be a little over 16 million. Let us take an example. 1.0.0.0. This is our class A network address. It can have 16 million plus addresses for hosts ranging from 1.0.0.1 to 1.255.255.254. Note the first and the last address is not used. The first address, is called the network address. That is 1.0.0.0. So this is the network address that is used to identify the network itself. And the last address is called the broadcast address. And that is 1.255.255.255. And this broadcast address is used to send data to all the hosts on this network. Another important thing that I want to touch upon over here is the default subnet mask. Default subnet mask. Like every host on a network has a unique IP address, similarly every network address has a unique subnet mask. Computers use these to determine the network part and the host part of an IP address by ANDing the IP and the mask. The default subnet mask for all class A network address is 255.0.0.0, or you can say that in binary. The ones in the subnet mask represent the network part, while the 0 bits in the subnet mask represent the host part. Some people write it like this, /8. So this is known as the slash notation. Gentlemen, let me repeat these for class B and class C as well, for your better understanding. Excuse me. Let's talk about class B network address now. Class B network addresses. So it moves the same way as we have talked about class A addresses. Every class B network address has 2 octets reserved for the network part and 2 for the host part. We can write it as n.n.h.h. Since there are a total of 2 parts for the network, so we have 2 raised to the power 14 minus 2 addresses for class B. They range from 128.0.0.0 to 191.255.0.0. Similarly, the number of hosts, since there are 2 octets for the host part, we can have 2 raised to the power 16 minus 2 hosts, 65534 almost. Let me describe this with an example. Suppose 128.0.0.0, this is a class B network address, and the address range of the hosts that can be there are 128.0.0.1 to 128.0.255.254. You can note again over here as well, the first address is not used, and that is the network address, and that is 128.0.0.0. Similarly, the last address, the broadcast address, that is also not used, that is not assigned to any host, 128.0.255.255. And last but not the least, the default subnet mask for class B. That is 255.255.0.0, and you can write it down in slash notation as /16. Maybe some of you might have observed that we have missed a bit of addresses like 127.0.0.0 to 127.255.255 192.168.255. These address ranges are reserved for loopback and diagnostic functions. In most of your computers, you might have seen 127.0.0.1 as a loopback address. Okay, so let me move on to class C network addresses now. Class C network address. So in class C network address, we have 3 octets for the network part and only 1 octet for the host part. The total number of addresses are 2 raised to power 21 minus 2, and their range is 192.0.0.0 to 192.255.255.0. Similarly, the number of hosts for class C network addresses, they are 254, that is 2 power 8 minus 2, because we have only one octet for the host part. Let me take the same example as I have taken before. 192.0.0.0 is a class C network address with the address range of 192.0.0.1 to 192.0.0.254. We can assign these 254 addresses to host. Here again, the first address, that is the network address, that is not assigned to any host, 192.0.0.0. Similarly, the last address, which is called the broadcast address, is also not assigned to any of the host, and that is 192.0.0.255, and the default subnet mask for class C addresses is 255.255.255.0 or the /24 notation. So these are the addresses for class A, B, and C. After having the fair idea of this, let me move ahead and let me touch upon a concept that is known as subnetting. Subnetting. I'll just briefly touch upon this. Will not go into the details. Subnetting basically is a technique of dividing a network into 2 or more smaller networks. Consider an organization. Having a lot of computers. Let me draw the diagram. There is a switch over here, and these computers are connected via this switch, and there are about 100 computers for the sales department, and there are about 100 computers for the accounts department, and this is a router. Okay, so let's suppose that this organization has a class C network address of 192.54.6.0. So this is the network address of this organization. So the broadcast address will be 192.54.6.255, and the default subnet mask, as we all know, is 255.255.255.0. So we have 254 available addresses to be assigned to the host, and the address range can be 192.54.6.1 to 192.54.6.254. So consider this scenario. Now, since there are 2 departments in the company, the sales and the accounts, each having more or less about 100 hosts with address range as shown. For the security purposes, the company wants to divide the network into two sub-networks so that the salespersons cannot access the resources of the accounts and vice versa. So this can be done using subnetting. Let me draw a diagram first. Let me draw the sales computers which are connected with a switch. Let me have this subnetwork, and then we have the accounts computer connected with a switch. And both these subnetworks are connected via a router. Since we need to have two subnetworks now, so the technique is just to borrow one bit from the host part to the network part. So the new subnetwork mask becomes something like this. Let me change color. 255.255.255.128. Let me write it in the last octet in binary. 1. So we have used a 1 over here because 1 bit is enough to represent two subnetworks. If we need to have 4 subnetworks, we would have taken 2 bits from the host part to the network part, from the host part to the network part. Okay, so let me write details about the sales subnetwork. The sales subnetwork address will be 192.54.6.0. The broadcast address will be 192.54.6.127. The address range will be 192.54.6.1 to 192.54.6.126. So we have about 127 hosts available over here. This is the network address, and this last is the broadcast address. Over here again, for the accounts department, the network address will be 192.54.6.128. The broadcast address will be last address, that is 255, and the address range will be, that can be assigned to the host, 192.54.6.129 to 192.54.6.254. And remember the subnet mask for both these networks is this. Okay, so advantages. What are the advantages? Why we do subnetting? The advantages of subnetting are advantages. Let me write it down. Why we do subnetting? The first advantage is it enhances the security of the network. Enhances security of network. Another advantage is it increases the routing efficiency. Increases the routing efficiency. And last, it of course reduces the size of broadcast domain. So this is what subnetting is. That is, dividing a network into two or more smaller networks. Supernetting. Supernetting or CIDR. Classless internet domain routing, sometimes called supernetting, is actually a way to increase available internet addresses. Let me write it down. A way to increase available internet addresses. Internet Corporation for Assigned Names and Number use this technique nowadays, which has significantly extended the useful life of IPv4. ICANN has taken away many Class A and Class B addresses from organizations and is using them to create IP addresses with lesser number of host computers and then issuing these IP addresses to organizations. Let me give you an example for better understanding. Excuse me. Let us consider /28 networks. ICANN controls the leftmost 28 bits for the network part, with remaining 4 bits under the control of the organization it is issued to. The subnet mask for such a network is 255.255.255.240. In binary, I can write it as. So these 4 bits of the host part is given to the network part, and we are left with 4 bits for the host part. So there are a total of 16 IP addresses available for the organization. Now the question arises is, what if the organization is having more than 14 hosts? The solution to this is private IP addresses. So what are private IP addresses? Let me open a new board for this. Private IP addresses. IETF, Internet Engineering Task Force, has designed 3 address ranges as private. 3 address range for class A and B and C. And these addresses are non-routable and are only used either on a fully disconnected network or on a network behind a firewall. Let me write down the IP address ranges for you. For class A, the IP addresses which are private are ranging from 10.0.0.0 to 10.255.255.255. The total number of addresses that are available this way are 2 raised to power 24, and the subnet mask is 255.0.0.0, or you can say /8. Similarly, for class B, the IP address ranges are 172.16.0.0 to 172.31.255.255. The total number of addresses are 2 raised to power 20, and the subnet mask is 255.240.0.0 or /12. Similarly, the IP address range corresponding to class C are private IP address range are 192.168.0.02, 192.168.255.255. The total addresses are 2 power 16, and the subnet mask for this is 255.255.0.0, or you can call it /16. Now, everywhere in an intranet, the organization uses these private IP addresses. The problem which comes up now is how a computer with a private IP address can access the internet. The solution to this problem is NAT, Network Address Translation. NAT basically allows a single device called a gateway computer or a router having a public IP address to act as an agent between the internet and the local or private network. So this means that a single public IP address can represent an entire group of computers. This is done for both economy and security purposes. So let me write an important statement, that is CIDR, that is classless internet domain routing, and netting. Both these techniques have significantly extended the useful life of IPv4. So that is why I have said that IPv4 is still today, while IPv6 is a tomorrow. In some future session, we will learn how to implement netting on Linux using IP tables. So now we are done with the addresses on the internet layer, that is IP addresses. The last part is the addresses that are used on the last layer, that is the network interface layer. Network interface layer address, that is MAC. Media access control address. This is a 48-bit address, gentlemen. This 48-bit address is divided into 6 octets. The first 3 octets, normally represented in hex, represent the company or of the network interface card, and the other 3 octets on the right side, they uniquely identify that computer or the network interface. Let me tell you how it is used, how these MAC addresses are used while sending and receiving packets. Right, students, if the destination IP address of a network message that needs to be sent on the network is not in the same local network, then it is sent to the gateway and routing is done. In case if the destination IP address of a network message is in the the same local network, then no routing is done, but ARP is performed. What is ARP? ARP is basically Address Resolution Protocol. Address Resolution Protocol is used to get the destination MAC address from the corresponding destination IP address. For this, the source computer operating system first checks its own ARP cache, and if the corresponding MAC address is not there, the source computer sends a request containing the destination IP address to all the computers in the local network using the broadcast MAC address, that is FF. Only the destination computer with a specific IP responds to this request with its MAC address. So this IP MAC mapping is kept in the ARP cache for future use as well. So this way, a message that is sent to a machine on the same network, no routing is done, and the MAC address is used for that. Okay students, this was just a kickstart for the subject of internetworking with Linux. I've tried my best to brush up some important concepts that are required for our future sessions. It was a bit tiring for me as the theoretical talk has gone longer than my expectation. However, I hope it is informative for you all. See you in the next session. Allah Hafiz and happy learning.